All right, in concept B, we're going to be continuing with working with precision, in this case specifically seeing how it is going to be reflected in our measurements. This is following up concept A, which talked about the definitions of accuracy and precision, so you might want to look back at your notes a little bit and back at our definition for precision. At the end of this lesson, you should have a basic understanding of how to reflect precision when recording measurements, especially in our labs this year. So precision of a measurement is limited by the instrument we use. Now, a method for handling this uncertainty in our measurements is the use of something called significant figures. This arises due to the fact that we have different equipment with different degrees of precision. So when measuring, we're always going to make an estimate of our last digit in our measurement. This represents the precision of the measurement. So here we have a triple beam balance. The 0 at the end, and we'll learn that that is in a very important spot in terms of our significant figures, is going to be significant. And thus, that's the last estimated digit. This idea of the last digit is an estimate can be referred to when we talk about volume. A beaker, because of how it's marked, we can estimate to the ones compared to this graduated cylinder where we can estimate to the tenths, and a burette which we can estimate to the hundredths. The farther the place value to the right, the more precise that equipment is, in this case measuring volume. That's why beakers we usually are used for mixing or transporting or having reactions occur within them, compared to the graduated cylinder, which we can actually use for measuring liquid volumes in our lab. And then we'll see later in acids and bases, we'll use a burette because we need a greater degree of accuracy. So what place value we round to, in this case for volume, shows us the precision of our instrument and kind of the degree of precision that's needed for a particular scenario. So when making measurements in the lab, we keep all the digits that are known exactly plus only one estimated digit. So how we're going to do that is that the number of digits be equal to the number of divisions the measuring device has plus one estimated digit. And this estimated digit is making the measurement actually more accurate than only using the digits that are known for certain or seen on the device. So this will make a little bit more sense once we get into these examples. So in this first one, we see that the device is marked to the tenths place. So that, remember, we estimate one additional digit or place value. So if it's marked to the tenths, we're going to read to the hundredths place. So again, one place value to the right. So this measurement, we can see that it's between the 0.4 and the 0.5. Okay, we're going to estimate to the hundredths, so I'm estimating between these two values to an answer of 0.48 centimeters. So the 8 in my hundredths place is that digit that's estimated. Instead of writing 0.4 or 0.5, by including that 8, we're making it a more precise answer. So here we have a device that's marked to the tens place. So that means we're going to estimate or read one additional place value to the right, which is the ones place. So I'm not going to just simply go with 60 or 70. I'm going to estimate to that ones place to get an answer of 67 centimeters. And again, that 7 is in the ones place, is an estimated value. Okay, and then our third example here, we have a graduated cylinder, so we're working with milliliters. If we look at this close-up view, we can see that the smallest place value is the ones. That means we're going to estimate one additional place value to the right, which is our tenths. So our correct volume with units is not going to be 43 or 44, but 43.1 milliliters. So that 0.1 is our estimated digits. And remember to include all units with all your measurements, so address your numbers. So go ahead here, you already have your units shown. You're just simply going to go through and see if you can give the correct measurements. So pause the video and then I'm just going to go through the answers and then we can cover any questions tomorrow in class. Alright, so for your practice problem number 1, you should have 46 milliliters. You have to make sure you don't have anything to the tenths. These were only marked to the tens place, so you can only estimate to the ones. In example number 2, we have 0.39. Okay, you can't have anything more or less than the hundredths place. If you had 6.40 or 6.38, those would be acceptable responses. Okay, and then the last one, number 3, we have a thermometer, and our answer here is negative 11.0 degrees Celsius. And again, your value should be rounded to the tenths place. in order to have that one correct. All right, so jot down any questions that you have right into your note packet so you remember to talk and ask me about them tomorrow. And then you are all set. I'll leave you with a little comment. Think about how the baseball glove is reflective of the lab instruments in class.